Hi, hello, how are you? My name is Anna Tenbenza. Welcome back to my channel. We're here another day going through as many LeetCode problems as we can in a year. I am now on question 90, which is subsets 2. I have not submitted anything for this yet. As you can see here, just got my daily check-in because I'm just getting on for the day. I know it's kind of late, but I had some stuff to do this morning. So let's go into reading the question here, which is, again, question 90, solution in Python, subsets 2. So, given an integer array nums that may contain duplicates, return all possible subsets, the power said. The solution must not contain duplicate subsets. Return the solution in any order. That seems pretty straightforward. We have the input here, which in this case is nums 1, 2, 4. We then have an output of nothing, 1, 1, 2, 1, 2, 2, 2, 2, 2. I mean, that makes sense to me. Then we have example 2 is 0, which is open, and then 0. So, okay. So let's read through this one more time, just because I want to make sure I'm not missing anything. So given an integer array nums that may contain duplicates, return all possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. Okay. So, the intuition I have is to use a backtracking algorithm for this to just generate the list of all possible subsets. So I think that's kind of what I want to lean into. I'm trying to think if maybe I could do this another way that would also be efficient and effective. But I think that's going to be one of the best ways to do this. And I kind of think I want to set up this backtracking algorithm with a recursive function. So, yeah, recursive function for this. But it's going to need 2 parameters. So we need the start of the current index within the nums list. So that's going to have to be 1, and then maybe path. Because that would be a list. Path could be the list that represents those, what's it called? Oh my gosh, what is it called, you guys? Subsets. Jeez Louise, it's right in front of me. Okay, this is my first question of the day, so I'm just getting my bearings. So let's start with backtrack, and same with the start and path. That way we can use that recursive function to generate those subsets, and using those 2 parameters. So like I said before, those 2 parameters use that current index within the nums list that indicate the element that we're currently considering. That's start. Then for path, that represents the current subset that's basically under construction, right? So in the backtrack function, we should append maybe the path to the results list, because that way we can keep a record of what of that current subset. So let me say, I move this, result append path here. Then we need to iterate through the elements in nums, starting from the start index. So we need for I in range the start and the length of nums. Not nuns. Not nuns. Anything but the nuns, the sisters. Anyway, okay, so then for each element in nums, if it's not the first element, because the duplicates, we may contain duplicates, but we can't have those duplicates. So if it's not, how could I say this? So I could say, if I is greater than the start, so we need to make sure the first element is not the same as the previous element, and then skip it to avoid the duplicate subsets. So let's say if I is greater than the start and nums I, nums I minus 1, then we continue. And this just effectively skips, yeah, I had that right. I don't know why. That just effectively skips the duplicate, which we have to do here, is skip that duplicate subset. Otherwise, we need to append the element to the path. So we're going to say path append nums I. And then we need to do with the recursive call backtrack, implement the start index, and passing the updated path. So we can say backtrack, I think I plus 1 and path, which should make sense. And then after that recursive call, we need to pop that element out. So then we're just going to say path pop. Yeah. Then we need to return the solution in any order. So if, I'm going to say for this, return the solution in any order. So my thought is to do nums sort, but even then that might be flawed. Because this, I mean, I guess this is in any order, but I'm not feeling like, we're just going to say nums sort. And if it doesn't work, it doesn't work. I'll just delete it. That's fine. And then we need to have the result list, and which will contain all of those unique subsets within that nums input list. But I need an empty path for backtrack. So I'm going to say backtrack. I need that to be take that 0 to start because we start with this empty thing. So I'm going to say 0 and then this and then return result. Okay. So given integer array nums that may contain duplicates, return all the possible subsets. This solution must not contain duplicates. Perfect. We figured that out, and return the solution in any order. So let's run this and see how we look. Okay. So just to reiterate, we did a backtracking algorithm for this using a recursive call for the backtrack function. So let's go ahead and submit it here and see kind of how we stack up. This took us about, what, 10, 12 minutes? Okay, runtime. She hot. Ooh, she hot. She's 99. She beats 99% of users with Python. Hot. Memory is 52%. I would have to say, for like 12 minutes of working on this, I mean, I think that's pretty good. I definitely think backtrack was the way to go for this. But again, there's a lot of different solutions that probably could work, but this is just the intuition I had to kickstart my day of LeetCode problems, as I do. So yeah, I will put this in the GitHub repo, which is linked down in the video description down below. You guys are more than welcome to fork it and clone it. You can make it better, you can make it worse. Just have some fun, learn something new. Thank you guys so much for watching, and I hope this makes sense. And if you have any questions, please, or comments, suggestions, questions, concerns, anything, feel free to drop it in the comments down below. And again, thank you guys so much for watching, and I will see you on the next video. Goodbye.